Okay, progress is being made. It's way slower than I was hoping. It's taking much longer than it should need to take, but it is happening. Okay, so you can go to agerank.com right now, and this is free. And you can look up this this system. And what this system does is it has so many biomarkers right now. Um, and you can go to like ApoB and you can take a look at like the whole, is that all the data? Wow, that's a little bit. You can filter it, male or female. You can put male, you can put BMI 0 to like 25. It's not enough data to get really clean lines with that sort of, um, but but it's getting there. So what you can do is you can put in your age, you can put in a biomarker, I don't know, like what if you put 80? And then you can plot um multiple points, so like 40 and 100 or something like that, and it'll show up. Okay, why am I doing all this? Um, because I want to know, I just want to know what every single biomarker looked like and which ones change with age and which ones don't change with age. And nobody else is building it the right way. Everyone else's stuff is really terrible. And so I had to do it myself. Let's take a look at cholesterol, LDL versus HDL. So you can see the variance at a glance. You can see, um, you can change a plot source. So for this one, I only have 2 years. Oh my God. All right. That's two. For LDL, no, don't have a lot. Where did I put systolics in? Yeah, this has got all the years. And I can put in custom data. So if I get data from clinics or anything like that, and they want to visualize it, it's super easy to just convert it. So each of these is basically a different data set. And the reason why we want like a whole bunch of different data sets and be able to swap between them is because if you have an idea about how something happens and you're like, well, does it happen like that all the time? It's good to have multiple sources of scatter plots. You need to see the variance. You need to see whether there's voids, zones, like not dead spaces is the wrong phrasing, but so like for cystatin, it kind of curves up and there's like these holes, right, in these ranges. Oh wow, this is the first time I saw this is combined. I think it's 1999 to 2003, just how NHANES works. Wow, that's crazy. Look at that density. But the curve is so clear. Um, so you can see where some of these are like variant like that, and other ones, man, I wish I remembered some of these better. I wonder if mean cell hemoglobin. So like some of these things will increase slowly, some of them will increase like at a extending rate. There's different ages where the inflection point is for different biomarkers. Some of them hold steady for a while, then they start to take off at around like age 50 or 60. Some of them will, they have different trends. Um, so like knowing where all the outliers are in this case, there's tons of people with low mean cell hemoglobin, right? These people down here. Um, and if you have a trend where something's rising up slowly over time, and you can see that, oh, there's people still down at this level. Is everyone rising? Like there's a lot of questions, but there's also a lot of information that is given by seeing the scatter plot rather than a simplified version of it. Um, I'm talking not necessarily to you, I'm talking to myself kind of because I have to now because like there's like 0.1% of people they're gonna watch this and actually know what's going on with all this data. And I've accepted that at this point. I've stopped trying to build this for other people, and it's just for myself at this point. I'm going to be able to use it to determine certain things. So for instance, if you go to C-reactive protein and you take BMI down to 0 to 25, the changes go away, right? So like, so which biomarkers are a product of just you getting fat versus you let's take a look at 25 to 100. Yeah, look at that curve. So you know, some of these biomarkers, they don't, God, that's so different. That's so different. It's the same exact data set, right? But if you go BMI 0 to 25 and you go from 25 to 100, God, it's just like it looks like a completely different graph. But that's why I wanted this thing here. And then you can so there's all this stuff that can be figured out. What I did was I went through and now I have a bunch of things like here's the biomarkers on the top that change with age. Oh, and then here's the ones that don't change with age. And then anything with blue is like in this page, it responds to BMI. So BMI pretty much fixes the things in dark blue, and then it modifies the things in light blue. And then in things in light red, it actually makes it worse for some reason. Um, and then green, it means I need more information. So I'm gonna put that in. So anything where I think I look at the data, here's what I'm gonna do for myself. I'm gonna look at the data. It's so tedious to put in every single year for every single graph. I think I will eventually get it all in the system, but oh my God, like it has to be done manually because there's no other way. There's no way to script it. So I'm going through and like generating each of these CSV files manually. And so there's like 10 per biomarker just right now, at this point, roughly 10 per biomarker. And not all the biomarkers are even in this system yet. So it's a pain in the ass. But I know how to do it, and I will be getting it done. But there needs to be a short list, and this is the short list. So everything that's tagged, I need to follow up by adding in the rest of the NHANES years, and then see if the trends that I'm observing still happen year to year for every single set of data, or if it changes around. Because that has happened with certain sets of data where I think, oh, here's what's going on, and then you look at a different year and the trend isn't there anymore. I went through and I found out which biomarkers have gender differences. And right now I only really care, I didn't go through the ones that don't change with age. I only really care about the ones that do change with age. Um, so these are the short lists for generating the full complete set. And maybe I can get that done by Friday. Oh, it's a lot of work, which is why nobody has done it yet. Let's see here. Was there anything interesting to see? HSCRP was interesting. Um, red cell distribution, cholesterol, triglycerides. I thought more of these would respond. LDL doesn't really respond to BMI. That's kind of weird. So if we go to LDL, and well, I only have 2 years in here so far, but if we go to LDL and we go to 0 to 25, system one. Okay, there we go. First of all, it's weird that the data changes like this. So I think I want to put more in here anyway, just to see like what's going on. It looks very different. But 0 to 25, the trend is pretty much the same, 0 to 100. right? It doesn't, I mean, the data is more scarce, so you get more variability with the floating point mean and median, but the trend doesn't look that much different. And then what I can do is check, so you can go 25 to 100 and then see if that affects it versus 0 to 25. Doesn't look like it does, which is weird. That means that LDL cholesterol is not related to like your weight, but supposedly if like you lose weight, shouldn't it be better? Again, it gets all messed, but the trend is very similar. So this is cross-sectional data, but it can easily hold longitudinal data. So if anybody wants to show longitudinal data, here's some gripes about the whole situation so far. I've seen other people's data sets and they're pretty crappy. And I've talked to people and they're like, oh, I've got like a, 50 data points, 200 data points. 200 is almost nothing. So each of these cohorts is around 8,000 people. Um, and you can see even with 8,000 people, there's still like some some things to be desired. It could be better, right? That this could be cleaner, but there's so much variance. Um, and so even 8,000 seems like underpowered. Uh, but people like if they have good data sets, I don't know, like nobody just they don't want to show them for some reason. I talked to SciFox and I showed them this thing because like they have a similar version, but it's worse. And I showed them this and then they didn't respond afterwards because I was all like, hey, you know, I want to know like, do you want to like visualize your data? Like, can I see your scatter plots? Like, because theirs is all box and whisker. And I talked to some other companies. They're all just like really bad at this. And that's a very arrogant thing to say, given the fact that I haven't been doing this for very long. But like I go through, well, it's a relative term, isn't it? Very long. But I'm going through like I'm I'm I've seen so many people's systems, uh, and they all suck, and they all just don't know what they're doing. Like there's nobody. First of all, very few people even have scatter plots at all, right? Because they want to hide the fact that there's so much variance and there's so much uncertainty. So what they'll do is they will put like error bars and like line graphs and all this kind of stuff. Those are completely useless because they're gonna change the data in ways that you don't. The problem is that the rules from 0 to 20, from 20 to 50, from 50 to 80, they change. And so you can't just draw a line through the whole thing. For HDL cholesterol, it looks like it doesn't really change over the lifespan, but for anything that actually does change, uh, like there's different rules for different sections of life, and you you can't just draw a line through it. And also because look how much variance there is. Like, okay, so if you take a look at how there's no real like lower bound for ferritin. Whereas if you take a look at like diastolic blood pressure, there is a lower curve where there's a void that emerges. There's a few people, and that'd be interesting to find out what's going on with those. Is it pathogenic? Did they get them in the middle of like a disease or like a pre-heart attack situation? I don't know what's going on with these people. But there's definitely a lower bound to this curve. So the variance is like centered around the mean and median. Whereas with ferritin, you've got this sort of a field where there's this density of data down here and it kind of drops off, and we've got this definitely have a some situation, and I don't think it's related to BMI, is it? Um, yeah, it's not related to BMI. So unless we even go further. No, not really. The trend doesn't really change. Okay. So we can see that it's not related to BMI. I don't know what's related to, but there's a pathogenic subpopulation pulling the average up away from the median. So this needs to be investigated. Is it related to wealth? Let's just take a look at that really fast. I don't think so. We need to find a variable where when you remove it, the red and the black are on top of each other. Okay, that's what you're looking for. Is what can you change about this data set that gets the red to meet with the black, and that's your pathogenic subpopulation getting removed from the system. Um, so there's also this density of data down here where there's no lower bound, there's no void space in this, and so you've got a situation where everyone's aging, right? 100% of people age, which means all the people down here are also aging, even though they're maintaining ferritin levels that are similar to ferritin levels early in life. You can see that there is a void space early life. So before you're 15, there's only 3 people that have ferritin of over 200 in this entire however many thousands of people cohort. So there's 3 people with ferritin over 200 before the age of 15. And then you've got this variance that occurs over here. Is it gender related? Mm, it is gender related. Did I write that down? Yes, I did write that down. I remember. This is a very distinct. So once you still have though, for just if you just take males, you still have the red pulled away from the black. That means um, pathogenic subpopulation is being some there's some outliers that are causing the average to move up way further than the median. Um, and it's not any of these. I don't think it's any of these. I've barely ever used ethnicity. These ethnicity buckets are just so bad. It's like almost useless. Yeah, I don't think so. Okay, so we can keep investigating and find something. Anyway, that's beside the point. The point is right now there's probably a lot of work to be done on this, but step one, version 1.0 is very close. I just need to put in the data for all these things to the 10th degree for the short list, and then I think I can just throw it up online and announce it. Oh my God. It's taken way too long. Like this could have been done months ago, but there's like random delays and I don't know, it's just it'd be so cool too. So this is all just NHANES data, but to have like UK Biobank, Denmark's national database, I don't know, something from Japan, something from other places. And I can put it in. It's not that difficult. Um, but we'll see if it gets there. So yeah, medical ranges, that's the last thing is to I think CRP. Does CRP? No. Which one had multiple? Was it LDL? There's only like a couple. Like most of the medical ranges I've found, like it doesn't matter what hospital or anything, they're all exactly the same. So it doesn't really matter. I thought it'd be a lot more variable, but standards, medical standards and whatnot, it's pretty good. They're pretty robust. There's a couple of them that have weird multiple data sources, and you'll be able to flip through at the flip of a button, and it's going to work. So the big thing was the plot source. Man, that's the big one, is to be able to just flip through and be like, oh, I want to see some other data set for cholesterol LDL, and does my conclusion make sense? And it only takes like a few seconds to figure out whether your idea is good or bad, instead of trying to go through having something that you think is a good idea and then thinking, oh, let me go do a bunch of research and like scour the seas and go on a epic voyage to try to figure out whether I'm right or wrong. And then it just takes like 2 seconds. Now it's so much better. Holy shit. Um, yeah, demographics are working. BMI is super cool. Wealth is a little bit interesting. Oh, I remember what it was. Systolic blood pressure. Um, so if we look at systolic and we look at male and we look at high wealth, right? We see from 2017 data, it looks like, oh, look, you know, you can cause systolic blood pressure to stop going upwards. If you include everybody else, you can see that it does trend upwards. 0 to 20 goes up, 20 to 50 stable, roughly, mostly. 50 to 80, that's when it loses control, starts to go up. At 80 years old, the median blood pressure is at stage 4 hypertension, or whatever the highest level of hypertension. That's median and average. So that means half the people are below, half the people are above in this red zone. Um, if you look at 2015 data and you look at male and you look at high wealth individuals, you're like, well, maybe the trend is the same. 2013, not really. So if we go from year to year, sometimes it's laggy. The trend doesn't quite hold up where you can high wealth individuals, look, this one just kind of goes up. So 2007, I noticed that it was the earlier years that, like, once you get into later years, it seems like maybe the drugs are getting better. I don't know. 2015, 2017, you've got high wealth individuals where the median and the mean are all staying kind of underneath the red zone. Whereas if you include 0 to 4, let's do that. This is pretty clear. 2015, 2013, 2011, you know, they're it's just rising. So you'd think, oh, it's the drugs, clearly, right? Or maybe it's just a lack of data. Maybe there's the same trend. Regardless, if you go to female, this is the important part. It's just where like every single year, you never see that. You never see it like flatten out. It's always trending upwards with no visible oh wow. 2001. That's crazy. Um so that's kind of interesting. But I had a thought. I was like, oh, and you see a trend, and it's like you need to look at like a whole bunch of different. So between 1999 and 2017, I just scanned through right there about 100,000 data points. And there are people out there trying to make conclusions using a couple hundred or maybe like 1,000 data points. And you need, you know what I mean? Like the conclusions are just like such like grasping at straws. Um, this was interesting. Uh, so most of the metals don't have any correlation to age, but lead does for some reason. I'm gonna put the rest of them in for lead later, but for some reason, lead uh accumulates, and it's not just like I'll give you an example. If we go to like cadmium or chromium, something like that. Um, so when you see cadmium like sort of accumulate with age, you think, well, it's kind of accumulating, but because it's pretty thick at the bottom, except for this last section. Might be just a fluke. Um, because there's a section at the bottom, it means that there's a lot of people that have zero cadmium for their whole life. And that makes sense. Like some people are going to be exposed, some people are not. As people get exposed, they pull the average up, they pull the median up less than the average, and then blah, blah, blah. Here's chromium, just most people are at like the lower detection limit, and then you've got some of these outliers. Okay, but with lead, you actually see a void space developing. It starts at around age 45 and it starts to come up. Now, what would be interesting is once I get all the rest of the plot sources in, so you have like 2009 or 1999 to 2017, if this is due to environment, right? Like everyone who's 45 or older, because they grew up in an environment where there's less lead regulations, they have more lead in their system. And that, like, in the future, we'll just see this thing trend outwards. If that's the case, then we should see some kind of inflection point marching across the screen in a reverse. So going backwards in time, it would be going to the left, I think. Yeah. Yeah. Because more people would have higher concentrations of lead in their system. Yeah. So if this marches across the screen, then it's environmental. But if the trend stays the same year to year from 1999 to 2017, if the trend, these inflection points stay at the same age, then it's not environmental. Even though this is cross-sectional data, it's actually specific to some kind of aging thing, which is weird because lead, you can definitely avoid lead exposure, one would think, right? Definitely. I use the word definitely, and it's like, what, questionable. Anyway, so it's all very interesting. Um, this is a really good start. This kind of solves step one, and then you can put in, I can get as much of this, I can know the short list, know what to track, and then put in my own data, and then see for every single one of these, I want to have some kind of box down here or something, some description somewhere on this page where it just tells you everything that anyone has ever figured out that changes every single one of these biomarkers, which is going to be, I guess that's step two. So step two is getting from one side of the curve to the other. And there's a lot of information out there, and it should all be in one place and easily searchable. It's just not because the organization um, of the internet is just so bad. Okay. What else was interesting to take a look at? Yeah. Oh, 20-foot walk. Is that working yet? It is working. It changes with age. I need to add that. So 20-foot walk. I have to go through and does it change with obesity? 0 to 25? Nope, not really. Are there gender differences? Male, not really. So it doesn't respond to either one of those. But one would not expect it either. The mean and median are kind of right on top of each other. Yeah. Okay. Why am I even posting this online? Uh, because if you've gotten to the end of this video, I guess I could use help on this project. Um, there's a lot of tedious work to be done, and that's fine. Do I trust other people to get that done correctly? I don't know. But just in general, like playing around with it, working on it, ideas for what else to do, coding help. Um, I got this whole system is dirt cheap for what it actually is. So I the reason why I got it done dirt cheap is because I actually know a lot about coding, so I know exactly how to describe things, and it makes it a lot faster to build this kind of stuff. Um, because I only need someone who knows the mechanics of JavaScript. The whole thing is in JavaScript now. Got rid of all the Python. It's all D3 library. Uh, test, test. Okay. What? Oh, okay. Um, yeah, it's just, I don't know, it's just really frustrating. Like, there's all these people running around claiming that they know how to do stuff, and then they don't, and it's really disappointing. What I've been doing, the psychological mistake that I've been engaging in is that um I keep just this like I keep taking people's word at face value. Uh and so like I think, oh, well if they say that they want to solve this problem, then they must actually want to solve this problem. No, most people in this field, they just want to make money, and it's really annoying. In my opinion, if you're here to just make money, uh get out because there's just like there's no money in this field unless you're dishonest, which I guess a lot of people are. Uh, there's not supposed to be money in this field because nothing works. So because there's no actual value being produced, you're not supposed to have a lot of money in this field at the moment. Um, yeah, I don't know what else to say. I mean, that's just the truth of it. If there was a lot of money in this field and nothing worked, it would be an indictment against like the natural human race instinct or efficiency of the brain to be putting tons of money into something where you're seeing no progress. That is just dumb. So I'm not surprised that there's not a lot of money, but it also means that you can get stuff done with very little, relatively little effort at this stage. I would be wary of anybody who is throwing vast sums of money and not seeing progress on whatever it is that they're doing. Sure, aging is hard, but like there's so many low level things that are just missing from the field, and they skip over that part. They skip over that kind of stuff because the investors are like, oh well, we want to see this, that, and the other thing, and it's like, dude, you don't know what. Here's what needs to happen in order to see that, and they just want to skip to it. They just want to skip all the actual grunt work. But hey, you know what? Maybe they all know what they're doing, even though they're making no progress. This is kind of interesting. Uh, the average is getting pulled up. I wonder how to get rid of that pathogenic subpopulation. But over here, you can definitely see the trend is the mean and median are pretty close to each other, and it's still got this arc, and that arc continues. And you've got this void space down here, which is very telling that, yes, see, if everyone's aging, then whatever aging is, first of all, must apply to everyone. It needs to apply to every single person because nobody on this graph is living to 200 years old, right? So even the outliers are not living to 200 years old, which means that it's an indictment against, hey, I've got low cystatin. I must have done. But if you can find things where there's like a void, a complete void, and you're like, hey, nobody's been there, and then you can try to get there for that biomarker, then you'll be aging in a way that nobody on the planet has been aging. Even this, there's only like what, like 5 people below, I don't know, whatever this value is, that are above the age of like 60. I think these might have been outliers that got left in. I'll have to check on that. Oh no, that's probably lower detection limit stuff. Probably errors. Doesn't look like it's enough to affect the curve though. Um, yeah, I was gonna say something else, but I don't know. There'll be more time. There'll be time later. The DEXA stuff was kind of interesting. Uh, GGT hemoglobin doesn't work right now because of an error in the JSON file, which I just updated, and so now I have to wait for the caching. Blah 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 before it can work again. Um, yeah, there's a lot. There's a lot. So we'll get the short list of all things that change with age. Oh, I remember what I was gonna say. Aging. So people are interested in mortality, and there's nothing wrong with that. I totally understand that. But what aging actually is everything that changes with age. That's what aging is if it changes with age, it's aging, which means anything that takes a curve like this, even if you can flatline it um for a while, and then it like maybe it rises, or maybe it just extends outwards, right? Um, anything that can modify a curve into a flat line is anti-aging. Anything that extends the curve is anti-aging. Anything that compresses the curve is pro-aging or speedy aging, whatever. So that's that's all. Like the definitions that people come up with are so complicated. They don't need to be. Anything that changes with age is part of aging. And there's actually a lot of things that don't seem to change with age. There's quite a few of these that just don't have any correlation to age whatsoever. Some of them very where did, oh no, it's not even complete. Is Clotho on this list? Where's Clotho? Serum Clotho. It's serum serum iron. That's interesting. See, I gotta check this again. Here's serum Clotho. It doesn't really change with age. What's going on here, right? And I got interested enough to come on, come on, 2009, 2011, 2013, 2015, right? Like some of these show like a slight decline. So if we do print screen in order to generate a line, it does show a decline, right? It's coming down. But if we do 2015, yeah, it's declining kind of, but it's staying flat up until was that age 65, 2009. How about this? Oh yeah. But see how much variance there is? So like there's people with these high levels of clotho, right? At age whatever. So maybe it's the relative change, which is where longitudinal data comes in. Is everyone coming down? You know, is it just bouncing all over the place? Is it like estradiol? Um, Here's estradiol. If we look at female estradiol. So because they don't control for when during the cycle they're measuring this, the estradiol from like when the period happens to it goes like whoop, and then it kind of does this like a weird shape. Um, because they don't control for when the last period was, you're getting the entire range from 0 to peak in this data set, which is why there's no clear curve and there's so much variance. If they controlled for the last time the period was, you could generate, I think, a curve that's much tighter than this, that's better, way better than this, and then you'll be able to put your own data in. If you're a woman, for guys, it's not. There's not a lot of there's not a lot of change for estradiol. There's a it's a pretty a flat line. So it doesn't change for males, but it does change for females. Um, which I didn't go over I didn't put the sex hormones in here yet because they're so obvious. Like, of course, they all change with. So we'll go estradiol. It's super obvious that they all change with gender, but um, or like they're all gender specific. Is testosterone in here? This is such a bad. This isn't old. I need to put in the other data. This is 1999 for sure, and it's just so terrible. There's no like, there's just not enough of the data. One. Oh yeah, that's right. Um, the other thing about the 1999 data was that they only took it from males. Not only that, they took, I think if you look at the sex hormone estradiol. So for estradiol, oh, I think it just doesn't even exist. Estradiol. Okay. But I think there was 1999 data. It's not this one, I don't think, but there was 1999 data where it was only male estradiol. Like they didn't take women estradiol. Like what? Like why? Like who cares? Like about male estradiol. Anyway, there's all sorts of weird quirks with the NHANES data set. Uh, yeah. Okay. Well, enough faffing about. I think that's pretty much everything. It's coming together. Hopefully by the end of the week, I can launch this thing. It's gonna remain free. I thought I was gonna make a business out of it at one point, and then I just got so fed up with like everyone and their grandmother are trying to do businesses out of this, and they're all really like it's really bad. And I think that if I did try to make a business out of it, like any the customers or the investors or whoever would just fuck it all up. I'm pretty sure. So I'm just gonna make this for myself. I'm gonna do it the right way, in a way that's actually useful. And I have to carry it all, I have to go the distance with it, which means I have to translate it for myself into some kind of a meaningful, objective, measurable change that I can say, hey, I did this thing and it worked. And that's when you can actually launch a business. Everyone else is just creating Ponzi schemes for uh, to drain VCs out of their money, which I mean, draining VCs of their money is a noble cause. But it's still, it needs to, something here needs to actually work at some point. So yeah. All right. Enough.